Hello everyone and welcome back to Educator.com. I'm Dan Fullerton and in this mini lesson we're going to go through page 1 of the A+ Physics worksheet on springs. You can find a link to the worksheet down below the video. With that, let's get started. Question 1. In an experiment, a student applied various forces to a spring and measured the spring's corresponding elongation. The table below shows his data. And question 1 says, on the grid at right, plot the data points for force versus elongation. So I've got a point here at 0, 0. I've got a point at an elongation of 0.3, 1.3 and 1 Newton, at 0.67 and 3 Newtons, somewhere right around there. At 4, at an elongation of 1, we have 4 Newtons. At an elongation of 1.3, we have 5 Newtons. And at an elongation of 1.5 meters, we have 6 Newtons. So there's my general look at the data. Number 2 says draw a best fit line. So to draw a best fit line, you're looking to have roughly the same amount of points above and below the line. I'd recommend using a straight edge, so it should look something kind of like that. All right, in number 3, using your graph, calculate the spring constant of the spring, showing all work. Well, the way we get the spring constant from a force versus elongation graph, if F equals kx, then k equals F over x. And we're going to get that from this graph by taking the slope, where our slope is going to be our rise over run. So what I'm going to do is I'm going to pick a couple points on the line that are pretty easy to use. And as we actually have 0 and our 1.5 meter line at 6 and 0, and that looks to fit our best fit line pretty well, I can actually use those easy points in this case. Where my rise is going to be, I go from 0 to 6 newtons, so we've risen 6 newtons, and our run is 1.5 meters, which is going to give me a spring constant of 4 newtons per meter. All right, moving on to number 4. A 10 Newton force is required to hold a stretched spring 0.2 meters from its rest position. What is the potential energy stored in the stretched spring? Well, what we know is potential energy is 1/2 kx squared. However, we don't have k yet, but we know that we have a force of 10 newtons when it's stretched out by 0.2 meters. And if k equals F over x, what I can do over here is I can replace k with F over x. So potential energy is 1/2 times k, F over x, times x squared. I can divide x and the squared. Therefore, potential energy will be 1/2 F times x, which will be 1/2. Our force is 10 newtons. Our x is 0.2 meters, so 10 times 0.2 will be 2. 1/2 of that is going to give me 1 Newton meter, or 1 joule. Answer 1. Number 5. A 5 Newton force causes a spring to stretch 0.2 meters. What is the potential energy stored in the spring? Well, we've got force of 5 newtons. squared, we can divide out that x to say that potential energy is 1/2 Fx. Now, we have 1 kilogram mass suspended from each of these. If each mass is at rest, how does the potential energy stored in spring A compare to the potential energy stored in spring B? As I look at this, we need to figure out really what x is going to be. Let's figure out x, that'll be F over k. So I'm going to replace that equation again. Potential energy is 1/2 times k, and my x is going to be F over k squared. So that'll be 1/2 k F squared over k squared. So I could also write this as, divide out the k, that will be F squared over 2k. The force on each should be the same because we have the same gravitational force on the mass. But the one that has the larger spring constant is going to have a smaller potential energy because k is in the denominator. So in this case, A has the bigger spring constant. It's going to have less potential energy. A has less potential energy. Kind of a roundabout way to get to the answer on that one. All right, hopefully that gets you a great start on springs. If this didn't go so well, now would be a great time to go back and review the more detailed lesson on springs. And if it went great, well, terrific. Go ahead, keep moving on. You're probably ready for the AP level questions. Thanks so much for your time, everyone, and make it a great day.